Okay. All right, let's begin by drawing 3 different circular angles in standard position, measuring 215 degrees, 575 degrees, and negative 145 degrees as we draw these together. Pay close attention to the details that we put on each picture. Okay. 215 degrees. What does 215 degrees look like?
Half a circle.
More than half a circle. Yeah, because half circle is 180, right? So we would have all of this plus a little bit more, right? How much past this?
35 degrees.
35 degrees more, right? So it'd be like all the way around, probably about to like right there. And this would be 35 degrees. Okay. So that would be 215 degrees. Half a circle plus 35 degrees more. Whew. What about 575? What would that look like? More than a circle. How much more than a circle? About 215? Is that what you said? Just 215. So it would go all the way around, and then it would start again, and then it would go 35 degrees past that 180 again, right? It's like a snail. So it starts here. This one starts here. Can't really see it with the pencil, but goes to there. This one starts here. That opens up. Boom, right there. Smack. What about negative 145? It's going to start here, but it's negative. So it doesn't go this way. Yeah, it goes this way. How far?
Plus 35 degrees? Or, no. 180 degrees minus 35.
Right, so it's still going to be a 35 degree difference. It just starts somewhere else, right? They're so pretty. What do all these angles have in common with each other? That 35 degrees, right? That's called a reference angle. That is a positive acute angle good gravy. Alright, that's the positive acute angle that the terminal side makes with the x-axis. Do you remember what a terminal side is? It's where it stops. What else do all these angles have in common? They all have the same initial and terminal side. Have graduation ushers been picked yet? Okay. Just checking. Alright, what's one difference that all these angles above have? What's one difference that they have?
They go differently.
Okay, so it's not necessarily lengths. They have different rotations. Either different amount of rotations or a different direction of rotation, but the rotation is different, okay? So they have a different arrow of rotation. Based on what you've seen so far, what are 4 vital things that all circular angles must have when drawn in standard position? Alright, well I have this. What's this called? Where you start. So that's the initial side. And the initial side, whoa, which... I think it's hot in here. Do you think it's like 1,000 degrees in this room right now?
Sorry, I'll leave.
What?
Sorry, I'll leave.
Something about Aldi's. You
No,
going?
he said, sorry, I'll leave.
Oh, I thought you were talking about a grocery store or
I'll
something.
make him leave.
No, it's okay. All right, and then they have an initial side, and what else do they have? Terminal side. And it's, just in case you forgot, it's a ray with the origin as an endpoint. They have, somebody said reference angle, that's right, they have a reference angle. And then what's the last thing that I drew on there? What else did I have? It's that thing right there. Do we know what that's called? Yep. It's an arrow of rotation. Alright, so those 3 angles above are called coterminal angles. So you don't have to write anything yet, but what do you think a definition of coterminal angles would be? What's a definition of coterminal angles?
Terminal side.
Uh-huh. Their terminal sides are in the same position. They have the same reference angle, but they have different arrows of rotation. So those, yeah. I'm about to own a dinosaur. Do you not have a pencil?
I have a pen, but I can't be writing that.
It's your notes, so I don't really care. Let's draw some angles. Draw the angle negative 470 degrees in standard position, then find one positive and one negative co-terminal angle with negative 470 degrees and draw them in standard position. Okay, so let's start off. Negative 470. So I know it's going to start here. If it's negative, do I need to start out by going up or start out by going down? Down. I'm going to go clockwise, okay, because it's a negative, so I'm going to go clockwise. How much? All the way around, and then I'm done? And then what? 110 more, so I go all the way around. So that's 90, and then like 10 more. It's gonna be, we'll say it's right there. What's this angle right here?
Which one?
So I went 360, then I went 90, and then I went 20 more. So what's this?
Oh,
This is
70.
20, this is 70. Okay. So that means our reference angle is 70 degrees.
So it's always like the angle from like the negative x-axis to the.
Yeah. See, it's the positive acute angle that the terminal side makes with the x-axis. Okay? So this is 70. All right, so now we need to find one positive and one negative co-terminal angle. So let's see. Since I had to go all the way around and then some more, what if I just did 470 plus 360? That would be a negative 110 degrees. So that would be a negative co-terminal right there. Keep forgetting to put my arrows on there. 70 degrees. What would it look like if I wanted to get there, but it be a positive? So I'm going this way to get right here. How am I gonna get that?
250.
It's 250?
I could use the 290s and add the 70 there.
Mm-hmm.
No.
Mathematically, how could I get that?
Oh.
Add 360 again? So like that. And that would be 250 degrees. Bless you. All right. Just as segments can be measured using inches or centimeters, like if I ask you how long is your pencil, and you could tell me that it was so many inches long, and you could be correct, or you could tell me it was so many centimeters long, and you could still be correct. Neither of them are wrong, okay? Angles can also be measured in different units. You have two type of angle units, okay? Degrees and radians. Radian measures are based on the unit circle. And that's going to be kind of a big thing, okay? By definition, the unit circle is centered at the origin, and has a radius of 1. See, 1 unit, the unit circle. See how that works? So this is a unit circle. What's the circumference of the unit circle? What's the circumference of any circle? What's the formula for circumference? 2 times pi times r. Well, this radius is what? 1, so that's 2 times pi times 1, or 2 pi. Alright, so you've got to set up a little bit of algebra here to see how to get from radians to degrees and degrees and radians. So what do you have to multiply 360 by to get to 2 pi? Because 360 degrees is an entire circle. 2 pi is an entire circle. So 360 times what gets me 2 pi? Well, let's just figure that out. See, we've got 360x equals 2 pi. So if I divide by 360, divide by 360, x equals pi over 180. This is what we're going to call our conversion factor. I still have like 20 seconds left in here. I'm just kidding. Where do y'all play?
Hawks.
Oh, that should be fun.
I won't be there. I thought you'd want a head start, and I was going to murder you once I catch you.
I have that recorded. That you're just starting to kill him. It's on tape. Not really, but still.
In the mail, right in the mail.
Yeah, what is that? Is it shiny?
Shiny, sparkly.
Oh my gosh.
Just touch it.
I think.
There you go. There it is.
Get these out. Oh yeah, let me see that one. Yeah.
Let's see.
That one, yes.
Yeah, you really need that.
Yeah. Love it.
Buttons.
Yes. What fun. I put it in there. I promise it's in there.
Yeah. You gotta watch.
This weekend, this is what we do on the weekends, is we play in crowns and stuff with sashes and buttons that say prom court. Okay. So this is our conversion factor. This is how we're going to get from degrees to radians and radians to degrees, okay? Because 360 degrees equals 2 pi radians. To convert from degrees into radians, you take your degree and you multiply times pi over 180 degrees, and that gives you radians. If it is already in radians, then you take your radian and you multiply times 180 degrees over pi, and that gives you your degree. So let's try one. So 90 degrees, so that's going to be 90 degrees times pi over 180 degrees. They kick you off the team?
Not fair.
Oh, okay. What? That doesn't seem right. Okay, now, I like to cancel because I don't want to actually multiply any of this stuff out. So, 90 goes into 90 once, and 90 goes into 180 two times. And degrees over degrees cancel out, so you're left with pi over 2. That's your answer. Get put little rads there. We'll actually stop labeling radians, but just so you remember what they are for now. Negative 235. This one's not going to be as pretty. The degrees cancel out. Let's see. I don't know that they have anything in common other than 5. 5 goes into 235 47 times. And 5 goes into 180 36 times. Alright, 2 pi over 3, and I want to change this back to degrees, so I'm going to multiply it times 180 over pi. Now, sometimes people are like, oh, I can't remember which one to multiply by. Just remember what you have to cancel out. If you're trying to cancel out the pi, and there's pi on top here, then the pi has to be on bottom here, or they're not going to cancel out. You're going to end up with pi squared, and you didn't do anything but make your problem a lot worse, okay? So these cancel out. Those are gone. Let's see. 3, doesn't it go into 180 like, what, 60 times? And then 2 times 60 is 120, and I have a degrees left over. Negative 13 pi over 6 times... Now, is this going to be 180 over pi or pi over 180? How do you know that?
You're canceling the pi.
Right, you got to cancel the pi out. 6 goes into 180 30 times. And negative 13 times 30 is a negative 390. I should probably check that math. Is that right? I kind of did that in my head. You know how that works out sometimes.
Yes, that's fine.
Okay. Coterminal angles with radians. Find one positive and one negative coterminal angle with negative 4/3 pi and draw them in standard position. Do this first by converting the given angle into degrees. Alright, so I need to change negative 4/3 pi into degrees. So what am I going to multiply by?
180.
Right. Those cancel out, and that goes to 60, so that's negative 120 degrees. No, it's not.
No.
It's
Let's
negative
just say, was it negative
240.
It's like,
I told y'all, you gotta check my math, especially on a Monday after spring break. Hello.
One of the worst Mondays of the year.
I know, right?
that in the first day back.
Mm. Well, at least on the first day back, first day of school, you at least have like a new outfit or something.
I think the worst Monday back is after a winter break.
That one is hard. Okay, so we're going to start here. And I have to go negative 240. So give me an idea of where that's going to be. Am I going to go past there?
Yeah.
Past there?
Yes.
How much?
2/3 the way.
2/3. Oh, some more fractions. So like right there maybe? What is my reference angle?
60 degrees.
Mm-hmm. 60 degrees is my reference angle. that's this one. That's just to see what this one's going to look like. Now I have to, actually it didn't tell me I had to draw this one, but it probably helps right now. I need one positive and one negative to go along with that. What could be a negative to go along with this?
Subtract 360.
Subtract 360. So negative 240 minus 360 is what, like a negative 600? So I'm going to go all the way around. And go, oops.
It's just gonna be the same thing, but just come up with an extra loop, right?
Yep. What's my positive going to be?
Yeah, 360.
Add 360. Negative 240 plus 360. Hey, there's my 120 degrees. $60. Okay, now we have to find one positive and one coterminal angle without converting them into degrees. So we have to do this in radians. We know where it's going to be, okay? We know that already. We know it's going to be right here. We know that this is going to be the angle. We just don't know how much that is right now. Or maybe, do we? Do we know how much this is in radians? Let's do the positive one first. If I have negative 4/3 pi, and I want a positive, I'm just going to, instead of adding 360, because we're in radians, I'm going to add 2 pi. Which is like adding 6 pi over 3. So that's 2/3 pi, or 2 pi over 3. It's going to start here, and I already know these are the same angle. They're just labeled a different way. So it's going to go to there. That's my positive one. I just need to know what this is as in radians. What's the difference between 2/3 pi, and if you'll remember, this is half a circle. If a whole circle is 2 pi, a half circle is pi. So what's the difference from 2/3 pi to a whole pi? 1/3, yeah. This is pi over 3. That's what that is right there. That's pi over 3.
So 60 degrees is pi over 30.
Mm-hmm. 60 is 1/3 of 180.
Yep.
This is 180. This is pi over 3. That's 1/3. That's 60. So.
Yeah.
All right, now let's do negative 4/3 pi minus 2 pi to find the negative one. 4/3 pi minus 6 pi over 3. And you get a negative 10 pi over 3. Oh my gosh, there's so many announcements. So just like the negative one that we did here, where we had to go all the way around and go back again to get to 60, we have to do the same thing. This is still pi over 3. It's no different.
So is 90 pi over 2?
Mm-hmm. All right. Given the angle theta, this is theta. That's what that is. Can you see that? That's theta. Determine the quadrant in which the angle terminates and find the measure of theta prime. Theta prime, also known as the reference angle. So if it's 275, in what quadrant does 275 end? Well, that's 180. That's 270. So 275 is going to be right here. But what's the reference angle? What's this angle right here? What's theta? Actually, theta prime. What? 85 degrees. Yeah. So that's quadrant 4. And theta prime is 85 degrees. About a negative 579. Good gravy. So I go 360. And what's left? 219? Yeah, negative 219. So that's 90. That's 180. So I've got what, like 39 degrees more?
Yes.
So that means theta prime is 39 degrees. So that it ends in quadrant 2 and theta, not Q prime. Theta prime is 39 degrees. All right, 13 pi over 6. Do you want to try this as radians, or do you want to change it to degrees? A whole circle is how much? In radians. 2 pi. Okay. It's 2 pi. I'm dealing with a base of 6. So 2 pi with a base of 6 is how much?
Pi over 3.
No.
Wait.
12 pi. Yeah, because 12
Yeah.
pi over 6, not 12 pi, but 12 pi over 6 would reduce down to 2 pi. Right? Does everybody see how this equals 2 pi, which is one circle, right? Yeah? Okay, so is this more than or less than one circle?
More than.
It's more than, because 12 pi over 6 gets me right here. But I have to keep going. How much more? 1/6. How about pi over 6? 1/6 pi. Yeah. So it ends in quadrant 1, and theta prime is pi over 6. Because I was at 12 pi's over 6. I need 13 pi's over 6. So I just need one more pi over 6 to get there. All right, what about this one? First of all, what's the whole circle going to be on this one? 2 pi would equal what for this one? 10 pi over 5. That's one whole circle would be 10 pi over 5. Now this one is different because this one's negative. So I'm going the other way. I'm going down. Oh my goodness, that's like a straight line. It's not even a curve. What up? So I'm going down. How far did I just go right there? 90 degrees. Pi over 2, right? Basically like a fourth of a circle. I went a fourth of this. So if I did try to do that by a fourth, it's 2. All right. So how much more do I need to go? I just went pi over 2, but I gotta make it 3 pi over 5. So this would be like 6 pi over 10, and this would be 5 pi over 10. So I need to go just 1 pi over 10 more. But then what does that leave right here for theta prime? If all of this is 2 pi, what did I just take out? Okay, let me ask you this question. I took out 3 pi over 5 from 10 pi over 5, which would leave, you said it, I think. How much would that leave?
Wait, what?
I took this much out. That's what I cut out.
7 pi?
Okay, leave 7 pi over 5. But wait, that's not your reference angle, okay? All of this from here to here is 7 pi over 5. But I just need this little part right here. What's this? It's pi. It's pi. It's 5 pi over 5. Because cancel it out, it's just pi, right? So this ends in quadrant 3, and what's my reference angle? What's 7 minus 5? Yes. And guess what? We got finished just in time for you to get to your day 64 homework.
We got atomic clock.
Yeah. Day 64 homework.